Okay, so now we're going to look at cost concepts. And cost concepts are really just the inverse of our productivity concept. Remember that if we want to produce more, we have to hire more people, and that's going to increase our cost. So you want to remember that we had two key inputs into the production process. Fixed inputs, like machinery and equipment, and variable inputs, like labor. Well, each of those have a cost. So we call the cost for fixed inputs fixed costs. Total fixed costs, T means total, and then FC means fixed cost. You might see it without the T. It just means costs that do not vary with output. Then you will see variable costs, and these are, the T again means total variable cost. These are costs that do vary with output. And then we have total cost, which is simply the sum of total fixed cost and total variable cost. And so here's total cost equals total fixed cost plus total variable cost. You want to write this formula down in a place where you can easily find it because you will be using it again. Let's look at some total cost data and see how we would graph this total cost data. So I want you to take a look at the column right here. It says total product. Now note that down here we have Q, and that's going to be the symbol from now on for total output. Okay, and we have 0 to 10 units being produced. Then we're given a column with the fixed cost. In other words, how much did it cost us for that equipment? And remember, that is not going to change. So if we were to graph this out, what we would do is we would put output on the x-axis and cost on the y-axis. Now note that it doesn't matter how much we produce, our total fixed costs stay the same. So that is going to be a graphed line that is just straight at $100. Okay. Now let's look at our total variable cost. Now variable cost is going to increase when we produce more product. So if we take a look at our total variable cost, you can see that our total variable cost has a different shape. It increases as our output increases. Now, this little bracket right here, all this space here represents our variable cost. Then our total cost is the addition of our total fixed cost and our total variable cost, and that's demonstrated by this blue line. And note that we have 100 right here. Why? Because that's our intercept later on in calculus. This will be our intercept. And then we just layer our variable cost on top. So our total cost is the distance from the blue line down to the horizontal axis. Now, important, this spread right here between total cost and total variable cost, that's our total fixed cost. And the value of this spread is $100, which is our total fixed cost. Okay, so these are our total cost curves. Okay, so now we have some cost formulas that we're going to have to look at. As we produce more output, we want to know how those costs are spread across our fixed components. Okay. Then we want to know how those costs are spread across our variable components. And then we want to know the average total cost and then the marginal cost. Okay, so some of these words should seem familiar to you. Average, remember under average, we're getting a total number. We're dividing it by something else to see how we could average it out. Okay, so the formula for average fixed cost is going to be equal to our total fixed cost divided by our output. Our average variable cost is going to be equal to our total variable cost divided by our output. Our average total cost is our total cost divided by our output. So these are formulas that you need to learn. You need to memorize them. You have to just get them in your head. And it's the easiest thing to do is just to think about what the words mean. Average, you have 10 candy bars and 5 little boys or 5 children. How many candy bars does each child get? So 10 divided by 5 means they each get 2 candies, right? So we're just averaging. Then the next thing you want to do is you want to look at average what? Okay, in this case, fixed cost. In this next one, variable cost. And in this next one, average total cost. Okay, so pay attention to what the words say, and that will answer your question about what is the formula. Now, another formula that is interesting, if you took average fixed cost plus average variable cost, that would give you your average total cost. Okay, so write these down in a place where you can find them, because you're going to be using them a lot, not only here, but in your future classes. Now we have one more cost concept, which is called marginal cost. So there's that word again, marginal. What does it mean? Incremental, additional. So what we want to know is, what is the additional cost of producing that last unit of output? Okay, I produced my 10th pair of blue jeans. How much did that 10th pair cost me? So to find marginal cost, again, we're going to use the same type of formula. This is going to be the change in cost. Whoops, I see a little error. Hold on just a second. Okay, so marginal cost is the change in total cost divided by the change in output. So change, again, that's basically the difference, right? So we're going to take total cost 2 minus total cost 1 divided by output 2 minus output 1. Okay, so think. What does average mean? It means you're taking the total and you're dividing it by a number of units and you're spreading the cost out. Or in previous example, the marginal, we're spreading the production out. What is the average? Now, what does the word marginal mean? Remember that marginal means additional. How do we find marginal? We take the change in the total divided by the change in some variable. So we're going to be using those two concepts a lot, and it's just easier if you understand it and what they mean. Okay, so now let's look at some short-run cost schedules. Okay, you will note that we have here our total cost data that we saw previously, right here. But now in these next columns, what we have done is we have taken these numbers and we've divided it by the output to get our average data. So here we have average fixed cost. So we're going to take average fixed cost equals total fixed cost divided by quantity. So here's your total fixed cost, and we're going to divide it by the number of units being produced. So 100 divided by 0, that doesn't count, right? So you just put nothing there. You can put a line there. Then we're going to go to the next level. Okay, total fixed cost 100, total product 1. 100 divided by 1 gives us $100. So that means that the fixed cost associated with production is all being absorbed by 1 unit of output. If we produce 2 units of output, then we can spread the cost across 2 units of output. If we produce 3 units of output, we take $100 minus 3 units of output, $33 per unit. So we're taking that cost and we're spreading it across the different units. If we have $100 of fixed cost and now we produce 4 units, that means that this $100 is allocated across those 4 units, and that gives us $25 average fixed cost. And so we continue this process, and you will note that as we increase our output, our average fixed cost starts to go decrease, 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 decrease. Okay, so let me see if I have a graph here for you. This is our average fixed cost. So when we produce 1 unit, on average, that 1 unit bore all the costs associated with production. But as we produce more, okay, each of these units bore half the cost. And if we produce 3 units, now they split that cost up. If we produce 4 units, it's across 4 different units, and so on. So our average fixed cost is going to decrease and continue to decrease the more units that we produce. Okay, so this is the shape of your average fixed cost curve, and you have some assignments that ask you to graph those. Okay, so let's go back. Now we're going to do average variable cost. So what do? We know we're going to take the average of the variable cost. This is our variable cost curve right here. Okay, and we're going to take this variable cost curve and we're going to divide it by our output. Okay, so average variable cost equals total variable cost divided by output. So total variable cost is 0, divided by 0, nothing there. Okay. We produce 1 unit of output. Our total variable cost is 90. So 90 divided by 1, average variable cost is 90. We produce 2 units of output, and of course our variable cost is going to go up because we had to hire more inputs. So 170 divided by 2 is going to give us an average variable cost of 85. Okay, we produce 3 units of output, and we go to our total variable cost curve where there are 3 units of output being produced. 240 divided by 3 gives us $80. Now you note that as we continue to produce more 3 units, our variable cost is, 3 units, and our variable cost is 240. Average variable cost is 80. If we produce 4 units, our total variable cost is 300. So 300 divided by 400 is going to give us $75 per unit. On average, $75 of average variable cost. If we produce 5 units, our total variable cost is 370. So 370 divided by 5 gives us $74. So note that our average variable cost is decreasing as we produce more units of output. If we produce 6 units of output, our average variable cost is $450. So 450 divided by 6 gives us $75. Up, so we can see that this is down, it bottoms out, and then it starts to increase, right? If we produce 7 units, our average variable cost is our total variable cost is $540. So total variable cost of $540 divided by 7 gives us average variable cost of $77.14. We produce 8 units, our total variable cost is $650 divided by 8 gives us $81.25, and so on. Now, I think I've been maybe misspeaking a little bit. I've been saying average variable cost. Column 3 is your total variable cost. You're going to take this total variable cost divided by your output, and that's going to give you your average variable cost over here in column 6. Okay, so note that this data decreases, decreases, decreases. It bottoms out here, and then it starts to increase. Okay, so let's take a look at what our average variable cost looks like. Okay, so there's our average variable cost. You see how it decreases and then it increases. Okay, so kind of like a smile, right? And so the spread from this curve down to your horizontal axis. Okay, so like at 3 units, if you went up to here and then across, then you would know that roughly 3 units average variable cost looks to be $80, right? More or less. 4 units you produce, and I think the average variable cost was about 75. Okay, so that's the spread here, and you carry it over to the y-axis, and that will give you the value. Okay, so for example, in average fixed cost, we had 2 units. We hit here, and then we come across, and we see that average fixed cost was 50. Okay, if we're looking at average variable cost, we would go 2 units, pop it right up to here, and that would be, I think the number was 85. Okay, so anyway, average variable cost. Okay, so finally we have average total cost. So how do we calculate this? Total cost, which is column number 4, divided by output, which is column number 1. So that's one way to do it. Can you think of another way to calculate it? Yeah, remember, average fixed cost plus average variable cost gives us average total cost. So you could put a plus sign here between these two, plus equals. Okay, so sometimes you might have data in different formats, so you want to be able to manipulate this information. All right, so let's take a look at average total cost. So, okay, so when we are producing 0, well, we can't really average that, so that's nothing there. When we produce 1 unit, our total cost goes to 190, so 190 divided by 1 gives us 190. When we produce 2 units, our total cost goes to 270. So 270 divided by 2 units is 135. When we produce 3 units of output, our total cost is 340. So 340 divided by 3 gives us 113.33. And so on. So we just continue dividing in this manner. Now note that average total cost is going to decrease, decrease, decrease. It's going to bottom out, and then it's going to start to increase. Okay. So let's look at, we're going to graph this, and let's take a look at this graph. Okay, these are average fixed cost, average variable cost, and now our average total cost. Okay, so note how this looks. This is much steeper here, and then it bottoms out, and then it starts to increase again. So in the average total cost curve, we're seeing 2 effects. Number 1, we're seeing the pull on total cost from the fixed component, right? So average total cost is going down, pulling down for 2 reasons, because the average variable cost is going down, but also the average fixed cost is pulling it down, okay? And then the average total cost starts to increase again, and that is attributable to the fact that the average variable cost is increasing, okay? So there's 2 factors at play on this curve. Additionally, the spread between the average total cost curve and the average variable cost curve is the amount attributable to the average fixed cost curve. Okay, so just to kind of recap, this average total cost curve captures the fixed cost, average fixed cost, and the average variable cost. And the spread between these also represents average fixed cost. Okay. And just a little point of reminder, remember that when we talk about cost in economics, we're including the normal profit. So you'll need to remember that for the next section. Okay, so let me go back to our final column, and that is marginal cost. Okay, so again, what does marginal cost mean? Change, right? So here, if we're producing 0 and we go to 1 unit, what is the change in output? Okay, so the change is going to be Q2 minus Q1. And then what is the change in total cost? We went from 100 to 190. Okay, so let me just graph this out here or write this out for you. Let's recall the formula for marginal cost. So it was, let me see if I can find a space here, TC2 minus TC1 over Q2 minus Q1, right? So that's marginal cost. So we're going to start here. Cost was 100 and it went up to 190. So 190, sorry, it's hard to draw on this, minus 100, that's our total cost, divided by the change in output here, 1 minus 0. Okay, so that's going to give us a marginal cost of $90. What does that mean? That means incrementally that last unit cost us $90 to produce, 90 more dollars to produce. And it's true because originally we started with $100 and now we're at $190. So it was $90 more to produce that one more unit. Okay, so let's go to the next level. I'm going to produce 2 units of output. So how do I figure out my marginal cost? I figure out my marginal cost the same way, but now I'm going to start, let's see, right here. This is going to be my total cost too, so it's going to be 270 minus, what was the previous cost? 190. And my output, I went from 1 output to 2 units of output. So 2 minus 1. So what was my marginal cost, or how much did it cost me to incrementally produce unit number 2? So 270 minus 190, I think that's 80. And 2 minus 1 is 1. So $80 divided by 1 gives us a marginal cost to produce the second unit of $80. Okay, so that second unit cost us $80 more. Okay, but note that $80 is less than what cost the first unit. So that means we're having our marginal costs are decreasing right now as we produce more. So if I produce a third unit, my cost is going to go up to $340. Okay, so what is my marginal cost? How do we figure that out? Okay, so let me erase some space, give us some room here. Whoops, sorry, didn't mean to do that. So let me erase the stuff that we already did. Okay, so we went from 2 to 3 units of output, and the cost was 300, went up to from 270 to 340. So total cost 340 minus 270 over 3 minus 2. Okay, so that is going to be what, 70 over 1. So it cost us $70 to produce the third unit. Okay, so marginal cost means additional cost for each unit that we're producing. How much is it costing us additionally? Okay, so now we're going to go to the fourth unit. And the fourth unit, or rather, when we started to produce 4, our cost went up to 400. So 400 minus 370. What was that, 370? Sorry, 340. 340 over 4 minus 3. That's going to give us, let's see, 400 minus 340 is 60 divided by 1 equals $60. So the fourth unit cost us $60. Okay, I'll erase all this stuff. Now we're going to go and produce more. Okay, we're going to produce the fifth unit. And when we do that, our total costs go up to $470. So what is the change? 470 minus 400 divided by 5 minus 4. So 470 minus, sorry, I said 500. I meant to say 400, okay? So like 470 minus 400 divided by 5 minus 4, that's going to give us $70. So the fifth unit cost us $70. So what's happening? Now we see that costs are increasing. We produce the sixth unit. Okay, the sixth unit. For 6 units, the cost is $550. So we're going to take $550. What does that change from the previous unit? 470 divided by 6 minus 5. And so that's going to be, let's see, 30. That's going to be $80. Okay, so now we can see that incrementally for each additional unit that we produce, our costs are starting to go up. Okay, so you can see that the costs continue to go up in this example. So we're going to graph it out. There's our average fixed cost curve, our average variable cost curve, our average total cost curve, and our marginal cost curve. Okay, now important things to note: marginal cost curve intersects the average variable cost curve. Hold on, let me get my little pointer up here. At the lowest point, average variable cost and marginal cost intersect here, and marginal cost intersects the average total cost at its lowest point. Okay, why does this happen? Well, remember our productivity curves from the previous section? Okay, our marginal product peaks at a certain point. Well, if our productivity is peaking, that means our costs are going to be low, right? So as we add more people to the production process, that means our incremental marginal costs are going to continue to drop. But recall that as we add more people to the process, what happens? Their productivity starts to decline. You know, that each individual extra person that we start to add doesn't add as much to output as the previous one. And so that means, on the flip side, our costs are going to increase. Okay. Same thing is true here with the average product. Okay, this is our productivity. Well, that is captured in the average variable cost curve. Okay. So the marginal product curve and the marginal cost curve are related. So if you're a manager, your job, of course, is to increase productivity. And when you increase productivity, you are reducing costs. Okay, so you have a problem like this in your homework to do. And again, don't panic. It looks very panic-worthy, but I don't want you to panic about it. I want you to think about it, okay? Think about what it's asking you. It's asking you total fixed cost. What are total fixed costs? It tells you right here, a firm has fixed cost of $60. Then it tells you total variable cost. Well, there it is, right? So now you have fixed cost and variable cost. You add these two together, that gives you your total cost. Then we have average fixed cost. How do we do that? Look at your formulas, the ones I asked you to write down. Fixed cost divided by output gives you average fixed cost. Average variable cost divided by output gives you average variable cost. Average total cost, two ways to do it. You can add these up and put it down here, or take total cost divided by total product, and then that's going to give you your average total cost. Marginal cost, recall, is the change in total cost divided by the change in output. So you will need to graph these. Okay, let's see. I left some room here in case we needed to jot down some stuff. Some things to think about with your curves is that there are going to be some things that will shift these curves. Okay, so if your rent goes down, okay, then your average fixed cost is going to go down and your average total cost will go down. Your average variable cost probably won't go down because rent is not a variable expenditure. Okay, if your labor costs go down, then your average variable cost would shift down and your marginal cost curve would shift down. If your variable costs go up, you know, like your rent go, no, not your rent, but like labor costs go up, or input ingredients go up, that's going to cause your average variable cost curve to increase and your average total cost curve to increase. Okay, so all that stuff is in your textbook. You can read all about it. Okay, the last thing I want to talk to you about is long run production costs. So what is the difference between long run and short run? Remember, in the short run, we have at least one input that is fixed. But in the long run, no input is fixed. It means everything can change. So a firm can change all input amounts, including how big it is. So for example, say you have a business and it's doing really well and you want to add more space. Well, when can you do that? Well, maybe when your neighbor business moves out, you can take over his or her space, or when your contract expires, you can move to a bigger location. Okay, that would be an example of changing your plant size. All costs are variable in the long run. And the long run average total cost is, we're going to be looking at the long run average total cost as a series of short-term costs. Okay, so if you think about it, what is the long run? The long run's a lot of short runs, right? So here we have average total cost 1 for one specific business size, let's say. If we produce right here at the lowest level of average total cost, okay, we can produce, say, this much output at average total cost. Now, if we wanted to expand output and, you know, produce more, so let's say, let me put some numbers here so we can see this. Incidentally, and I should have mentioned this earlier, when we're talking about average total cost, what we're really referring to, or one way to think about it, is per unit cost. Okay, what is per unit cost? Because that's what average total cost is. Okay. Okay, so let's put some numbers here. This is our Q, this is our output. It tells you right here, output. Okay, so for this size facility, we can produce somewhere between almost 10 units at a given price point. Okay, so this is, at a given cost. If we want to produce over here, for example, where did my cursor go? If we want to produce over here, maybe we want to produce 12 units or 15 units, and we're keeping the same plant size, our per unit cost is going to be really high. So in that case, it's going to be expensive to produce, and it's cheaper for us to produce at this level. Okay. So the question then becomes, how can we produce more and keep our cost low? So one solution is to expand into another facility. Okay, so if we expand into another facility, okay, we can now produce more units at a lower cost. But the minute we expand from one facility to another facility, we are in now we are in a new short run, right? And we're going to be producing at the lowest average cost, which is right here. Okay. Now, what if you are have such a popular company that demand is asking you to produce 20 units? Well, production of 20 units is actually going to be It's going to be more expensive than production of almost 15 units, right? So remember, you read the price over here. I didn't put prices here, but I'll put some numbers here because I know sometimes it's confusing. $3, $4, and $5. So if I want to produce, maybe I can get a different color of ink. Yes. Okay. Okay. Maybe I can produce 20 units, and that's going to cost me $4. So that's along my second cost curve, I had increased my capacity so that I could produce, 14 units at $3. But now demand is such that people want 20, but my costs are going to go up. So solution would be to expand again. Okay, so this process iterates over and over again. So I expand once here, average total cost curve 1, then again with my average total cost curve 2, okay, and then again average total cost curve 3. Now I can produce those 20 units at a lower cost, and I want to continue to produce, and I continue to expand. At some point, however, the size of my facility, and maybe I have to open up 3 or 4 or 5 facilities, it's going to be difficult to manage. And so now, because I might have management issues, my costs are going to start to go up. Okay. So when we hook together a bunch of short-term events, we have a long-term. So the long run cost curve is the envelopment of all the short run average total cost curves. Okay. So the long run average total cost curve envelops all the short run average total cost curves, and that becomes our long run curve. Okay. So we have names for this. Economies of scale will happen in the previous slide right here. As we are increasing our production, we're increasing our size, we are experiencing economies of scale, meaning that the bigger we get, the more specialized we can become, and the more we can decrease our costs. Okay. So we have labor specialization. People know what they're supposed to do. There's no training involved because they are, now becoming really versed in their production. We have managerial specialization. Managers are better able to manage. They have policies in place. We figured out our capital structure in terms of what kind of equipment works best, and a lot of other factors. Then we have another stage that's called constant returns to scale. And in constant returns to scale, it means that we've kind of bottomed out. Okay, we're increasing our capacity, but in terms of cost structure or costing, it's not decreasing. And then we have diseconomies of scale. And as the name implies, diseconomies of scale means that we begin to have control and coordination problems, communication problems between the facilities, worker alienation, and shirking. Shirking basically means people, are trying not to do their work. So, graphically, This stage right here is the diseconomies of scale. So scale means size. Economies of scale means that there's advantages to growing your size. Constant returns to scale means that it's the same. You grow bigger, your costs stay the same. Diseconomies means you grow bigger and now your costs start to go up because of management issues and so on. Okay, so along these concepts, we have something called minimum efficient scale. And this is basically where the lowest level of output at which long-run average costs are minimized. So what is the lowest amount of production that can occur where we still reduce our average costs? And this sort of concept, minimum efficient scale, determines the structure of industry. Okay, so we're going to get into the structure of industry, market structures, monopolies, and so on. So in a natural monopoly, long-run costs are minimized when only one firm produces the product. So let's see. So this is what the industry looks like. Average total costs are going down. Then they remain constant. And then they increase, and we have diseconomies of scale. But production changes, different types of businesses have different looks to their curve. Okay, it could be economies of scale very long. Before diseconomies of scale set in, notice not that much time period in constant returns to scale. And very little constant returns to scale. So we'll see this. We're not going to actually look at it in this class, but you see this in different types of industries. Okay, so I think that concludes our presentation. So if y'all have any questions, please let me know, and good luck.